Hello everyone, welcome to my YouTube channel CNC for TDM. Today in this video, I am going to explain a contour program, how to make a contour program on a software, CAM software. So this is a profile. I have drawn this profile and sizes are given here. This is, say this length is 60 mm, here 10 mm radius is there, 50 mm, this is height, and one radius is there 10 mm or 10. From center to this edge, this dimension is 25 millimeters, and here this is a chamfer of 10 mm into 45 degree, and this height here is 40 mm. So this way we can create a drawing on CAD software or CAM software. Just you create a drawing like this, and this is our x-axis here, this is y-axis. So that means this datum point, start point, this is x0, y0, this point. We will start toolpath from this point. We create a toolpath. Tool will go to this point, then it will make this radius, then this height and this radius and all the dimensions. So it's how to create this program. First of all, what I have to do is I have to go to job setup and I have to create this rectangle I have created for material size, this size of the material, and in this material you are creating this uh, contour program, this profile. We are making this profile. Okay, so first of all what I have to do is go to this toolpath and job setup. This is our job setup. So what is job setup? We have to define origin. This is our size of the rectangle, 129 point something and 130 point something. So we can select it here, and we have to define height of the block also, and then display stock you have to keep it on. And by selecting the corners we can select this rectangle. First of all, go to select corners. Just you select this edge and then this edge. These diagonals I have selected and it has taken these sizes, and here it is Z0. So you have to define some thickness. So let us say it is 20 mm thickness, display stock, and this is our stock origin, this point, center point. Okay. So we have selected this material size first of all, and now we have to create this profile. Okay, what I have to do is, first of all, you go to toolpath. This profile you have already created, given the dimensions, drawing, you have made this drawing. So go to this toolpath, and you will go to contour, toolpath contour. So you have to select the contour. How you have to select it? Chain, partial means entity one by one. Select the first entity. You just select this entity. Wait, yes. Then I have to select second entity, then third entity, then this entity, then this entity, then this entity, then next entity, and then last entity, and end here. Okay, and done. Now it is done. So now what I have to do is, this is your these are tool parameters. First of all, I have to define tool parameters, then contour parameter. These are two types of parameters. So tool parameter, I can say, if you right click here, you can get tool from library or you can create it yourself. So I will get it from library. Say this is a end mill. Say this is a flat end mill. I say 4 mm size. Okay. So 4 mm size or 5 mm or whatever is the size of the tool. If you click this tool here, right click, you will find these parameters of the tool. End mill, this is our end mill. Here it is given this length, flute length 50 mm. Here this is our header. Here this is our holder, tool holder. So the head number -1, tool number 1, it is given here. So this diameter, holder diameter is given 50 mm, and then arbor diameter is 5 mm. This diameter is 5 mm, tool diameter. So these all parameters. This is our flat end mill. And tool type, what type of tool you want to change, if you want to change it here. And these are the parameters of the tool. All parameters are given, feed rate, plunge rate, everything. Okay. So what I have to do is, I have to take this, I have to fill this form. Tool diameter is 5 mm, flat. Feed rate, how much is the feed rate, how much is the plunge rate, how much is the retract rate, length offset, dia offset, and these all the parameters I have to. And then by filling these all parameters, this is our sequence number, sequence start number 100, sequence increment, sequence 2. So all sequence will be like that, 100, 100, 200, 400, 6, like that in the program. Sequence number will be like that. Program number you can give here, this is 2000 program number, and you can give spindle speed also. So these are all parameters. Then is contour parameter. So this is contour parameter. What are the contour parameters? So if I am machining this, so this is our top of stock 0, this is our Z0, and this is depth here. If you want to say -2 mm depth of the contour, say it is -2 or -3, whatever it is. So this is depth, top of the stock, then it is depth. Then this is feed plane 100 mm. 100 mm is feed plane, and retract plane, this is 50 mm. Sorry, this is 10 mm. Feed plane is 10 mm. And this is our clearance plane here. This clearance plane is given at 100 mm. Like that. This is 100 mm. So these are all, because this is top of the stock. This is our feed plane, where it will come to the actual feed rate. This blue color is for feed rate, and yellow is rapid traverse. It will traverse in the rapid mode up to this yellow arrow, then it will come to the in the actual feed. Okay, these are all parameters. So if you don't want this compensation off, you can make it off, and this is your, it will be in the tool, will be in the center of the profile, like that. So let us take this example. So this way you can create this program. So now say, then you go to, what I have to do is, you just contour, then you chain, make it like that, and then you go to operations. So this is one operation. These are all parameters. So tool path is created here. So you can check parameters again here also. Say these are parameters. All parameters are given here. This depth is given -3 mm. Top of stock is 0. These are all contour parameters, 2D contour. And this is our tool parameter, 5 mm tool we have taken. This program number is 2000. Feed rate is 200 mm. Plunge rate is 20. Retract rate is 500. Sequence number, sequence start 100. Sequence increment 2. This is program number. Spindle speed is 1000 rpm. So this way we have created all these. Okay, these are all parameters, machining parameter and tool parameter you have to define. So after defining all these things, you say this is your uh, contour program. These are the parameters. This end mill is given here, flat end mill. This is the geometry details. Chaining we have already done. So, and now, so this toolpath, I want I want to verify the toolpath. Okay. So you go to verify. So you will get this animation. Okay. So let us start it machining. So this is our material and this is our contour. This is the contour which we have machined like this. So this is machining of the contour this way. So you can check it. Otherwise in wireframe also you can check it. How to check it in wireframe? Just go to backplot, and then you have to check it step by step. This step, this your tool is running like this. This blue color is machined like this. These are all steps and it is finally machined. So you can run it like this. Okay, so backplot is complete. So again, if you go to this, again if you want to verify, you just verify this, verify like this. So it is verified now, and now you can post it. You can run the post processor. Just post Hanuk save. Okay. 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 So this is our program is t.nci, t.nc is the program. Okay. Now let us see the program. Okay. How to see it? File, edit, editor, say it is a notepad. In the notepad you can see it. Okay. Edit nc. t.nc is the program. Open this file. So you have got this program. If you see here, this is a complete program you have got here. If you see, this is O2000, this is program number, percentage is for header, and this O means program number 2000 in Fanuc. So this is your start point, N100, line number 100, G21. G21 means it is in metric mode. So this is your given here, 102, G0, G17. G17 means it is in XY plane, G40, there is no compensation, and then G80, G90, so there is no cant cycle also. G90 means it is in absolute mode. And this end mill is given here, flat end mill. If you see this program, 104 T1 M6, tool number 1, M6, spindle start. Then it starts here, G90, X0, Y0. X0, Y0 is our this point. It starts from here, X0, Y0. Spindle speed is 1000 RPM. We have already defined it. Then in the next line, it is G43, H1, Z50. So this is our compensation, height compensation. So Z50 is the retract point. So then it goes to, because it is at X0, Y0, and it takes depth here Z minus 3 at a feed of 20 mm, which we have given in the program. Z minus 3 is the depth. Then if you see in the next line, X50. X50 means this is 60. Up to this point, linear cutting is there up to 50. Then R10 is there. Then it is x60, y10, r10. Next line, it is at x60, y10 and r is 10. Up, it will travel up to this point. Cutting will be up to this point. Then in the next line, if you see y50, g1 y50, it will go up to y50 mm. Y is 50 mm here. And in the next line, if you see, then it is x45. So it comes to, because this 50 mm flat distance is there, it will come up to this point, 45. Okay. And then again R10 is there, G0 to X25. This point is X25 here, and it will cut like this. G2 means it is a clockwise direction cutting. And then it will come to X10. It is a X10. This is X10. Then X0, Y40. This point is X0, Y40. It will come cutting like this here, X0, Y40. And then it comes to Y0, straight up to Y0 here. And then it retracts to Z50. And then M5 means spindle stop. And then G28 home position, Z0. So X0, Y0. So this way. And M30 is program stop. So this way you can do it. So this is complete program of with the help of software. This is a contour program. I think it's clear to you. Please like, share and subscribe. See you in next video soon. Thank you.